Your insistent chatter is so exasperating. I might be tempted to end for my own son.
No. I was just about to ask you something.
Evening, yes. Would never.
Hi, I'm Chucky. Wanna play?
Oh, please. You two are being overdramatic.
Oo, hindi. Siyempre nakasira ako ng table. Ikaw hindi, no?
It's not my fault. I can interpret your emotional Morse code.
Nakasira ako ng table. Gumagawa naman ako ng kasalanan.
It's not your fault.
Bakit di ko kasalanan? Ako may kasalanan. Ako nakasira ng table.
What's inside your bag?
You don't wanna know.
Counting ka ba?
If the table is sturdy, it can handle the weight of the backpack without much bending. But if it's weak and not well crafted, expect it to buckle up, leading to inevitable chaos. Huh?
What did she say?
It is called deflection of beam.
Reflection of what?
The deflection of a beam is a more detailed event where a structure bends under the weight of forces imposed upon it. Much like how people break under pressure, beams too experience their limit, but instead of showing emotion, they curve gracefully, strained by external load and their own material weakness.
Ang galing! Ano naman ang konsepto nito?
The concept is simple. Apply a force to a beam. It will deviate from its original rigid form. Its fate is tied to several macabre factors, like its length, material stiffness, and the mother which is strain. In the end, it's all just physics, bending reality ever so slightly.
Ha? Hindi ko pa rin gets.
How dreadfully annoying. Let's consider another scenario, shall we? Picture a horizontal steel beam, supported at both ends, like a simple beam. Now, envision a heavy object resting precisely at its midpoint. What will happen next?
I know, the beam will sag a bit in the middle because of the weight of the object. Opaque English.
I'm mildly impressed. For now. The ends of the beam stay put, while the middle bends under the weight. The extent of this deflection is influenced by the beam's material, its length, cross-section, and the load applied. It's almost as fascinating as watching a spider weave its web, both delicate and inevitable.
Ah, so isang halimbawa nito ay ang multi-story building. Ang floor ay parang isang beam. Kapag maraming tao ang nasa isang floor o mabibigat ang mga gamit, pwedeng ma-deflect ng konti ang sahig. Kaya pala minsan parang nagbabounce yung sahig.
Finally.
That's right. In the context of beam deflection, AI is called the flexural rigidity of the beam. It represents the product of modulus elasticity of the material and the moment of inertia of the beam's cross-section. Now, for our sample problem, makikita natin na merong pin and roller support ang ating figure. Ngayon, kailangan nating hanapin yung reaction at the left support, solving the moment of B. So, from A or AY papunta sa D, ang distance niya is 2 plus 5 plus 3 is equals to 10. Kaya magiging AY multiply by 10 dahil ang formula ng moment is force times distance. Ngayon, ang ikot ng arrow from A to D is clockwise kaya magiging sign niya is positive. Ngayon, ang 54 is downward papunta sa D. And ang distance niya is 5 plus 3 is equals to 8. ang downward papunta sa D ay umiikot ng counterclockwise. Therefore, negative ang sign. Ngayon naman, sa force natin sa C, 27 kN, papuntang D is 3 meters. So, 27 multiplied by 3 and negative 27 dahil counterclockwise ang ikot niya papunta sa D. Therefore, ang magiging sagot natin ay 51.30 kN. Yun ang ating AY. Ngayon naman, for the reaction at the right support or dy, which is hahanapin natin ang summation of Fy. So, ang summation of Fy is equals to 0. Ang AY natin is 51.30, positive dahil pa up, minus 54 dahil pa down, and minus 27 dahil pa down ulit. And lastly, yung dy is pa up, kaya siya positive, equal 0. So, kapag sinolve natin lahat yan, ang makukuha natin is dy is equal to 29.70 kN. Ngayon, kukunin naman natin yung moment at segment CD. Ang gagawin natin is magka-cut tayo between C and D. Pero ang distance natin, hindi natin ilalagay ang 3 meters. Bakit? Kasi nasa pagitan siya ng C and D. So, hindi natin alam kung saan siya banda. So, dahil kinat natin ang in-between ng C and D, maglalagay tayo ng arrow downward, then ililabel natin ng VCD. Ano bang VCD? Shear CD. And then, ang moment CD natin is counterclockwise. Ngayon, dahil hindi natin alam ang value or ng distance ng from C to D, gagawin natin na ang A to VCD is A or shear CD is equals to X dahil hindi natin alam ang total distance niya. Ngayon, kung ilalagay na natin sa formula agad, lalagay lang natin ulit yung mga sinulat natin na mga distance, which is 51.30 times X minus 54 times X minus 2 minus 27 times X minus 7 minus MCD equals 0. Then, dahil meron tayong X, hindi natin makukuha yung exact value niya. So, ang makukuha natin is equation ng moment CD. Ngayon, ang ating next na steps is hanapin natin ang flexural rigidity of Y double prime. So, ang Y double prime is equals to M, which is yung ginamit natin na moment kanina. So, gagayahin na lang natin siya kung paano natin sinulat kanina yung moment CD natin. Pero, imbis na open and close parenthesis, ang gagamitin natin is yung less than and more than na symbol, since it is a double prime. So, sa next is ang first integral. Dito sa 51.30x, maglalagay tayo ng 1 sa taas plus 1. And then, gagayahin din natin yung 1 plus 1 dun sa baba niya dahil yun ang formula or rule ng integration. So, magiging siyang 51.30x squared over 2 minus 54x minus 2 raised to 2 over 2 minus 27x minus 7 raised to 2 over 2 plus C1. Ano ba ang indication ng C1? Ang C1 is constant 1. Next is second integral. Dahil x squared yan, magpa-plus ulit tayo ng 1. And then, sa over niya, dun sa baba niya, sa denominator niya, mag-a-add din tayo ng 1. So, magiging siyang 51.30 over 2 x cubed over 3 dahil inad natin ng 2 plus 1 sa exponent and dun sa denominator. Then, minus 27 x minus 2 raised to 3 over 3. Bakit naging 27 na yan? Dahil ang 54, dinivide na natin siya by 2. Kaya siya naging 27. Then, minus 13.50. Bakit na naman siya 13.50? Dahil ang 27, dinivide na natin siya by 2. Kaya naging 13.50 na lang. Then, x minus 7 raised to 3 over 3 plus C1x plus C2. Then next, boundary condition at the left support. Solve for C2 or ang ating constant 2. Since ang gagawin natin is x equals 0 or the left support, ang left support natin nag-start tayo ng 0. Dahil ang x is equals to 0, hindi na natin kailangan mag-calculate. X is equals to 0, therefore C2 is equals to 0. Then, ang boundary condition at the right support naman natin, solve for C1. Ano ba ang right support? Ang pinakadulo ng beam. Ano ba ang distance ng pinakadulo ng beam? Ang distance is 10 meters. So, ang x natin is 10. Then, ang gagamitin naman natin ng formula dito is ang second integral or double integration. So, substitute x equals 10. Ang magiging sagot is C1 is equals to negative 382.05 kilonewton meter squared. Ngayon, sa equation of the slope naman, ang equation of the slope is equals to flexure rigidity y prime. Hindi na natin kailangan mag-solve dito dahil ang hinahanap is equation. Then, di ba sinabi natin dun sa first integral na yung C1 is constant siya dapat. So, dahil nahanap natin ang constant natin, i-replace lang natin yung C1 dun sa constant na nasagot natin kanina, which is negative 382.05. Kaya siya naging 51.30 x squared over 2 minus 54 x minus 2 raised to 2 over 2 minus 27 x minus 7 raised to 2 over 2 minus 382.05. Now, for our last equation, the equation of deflection. Ang equation of deflection is equals to flexural rigidity of y. Ano ba yon? Yung katapat niya ulit. Ano ba ang katapat niya? Yung merong raised to 3. Yung second integral or double integration. So, ang formula natin is 51.30 over 2 times x cubed over 3 minus 27 x minus 2 over 3 minus 27 x minus 2 raised to 3 over 3 minus 13.50 x minus 7 raised to 3 over 3 minus 382.05x plus 0. So, ganyan lang kadali ang computation natin ng deflection of beam. Ang dali, di ba?
Lo, sino ka?
Oo nga, sino ka?
Another annoying creature has shown up.
Dang it! That doesn't make sense. English.
Girl, you're so slow. The desk is firing beam, you know. It's like a flat surface supported by legs, so it could hold weight. Hindi mo kaya.
Kaya pala nung nilagay ko yung bag dito sa tulong ng table, nag-create siya ng downward force. Deflection pala yung tawag doon.
Exactly.
Yes. I suppose.
If the desk is constructed from sturdy materials and designed to endure weight, it can support that heavy backpack without much bending. However, if the desk is feeble or poorly crafted, the deflection could be quite excessive, resulting in catastrophic failure or worse, unceremonious breakage. How delightfully tragic.
Kung palaging naglalagay ang mga estudyante ng mabibigat na bagay sa desk na hindi matibay, ang constant na bending ay pwedeng magpahina sa structure over time. Kaya naman, sobrang importante na ang furniture ay dinisenyo na may deflection in mind. Gets?
Surprisingly, you've said something that's actually useful. How shocking.
Anong pwedeng gawing solusyon dito niyan?
To tackle beam deflection in classroom desks, here are some rather pragmatic solutions. Number 1, sturdier materials. Use high-quality materials like solid wood or reinforced metal that can withstand weight without much bending. 2. Improve design. Design desks to distribute weight evenly, perhaps with cross bracing or a thicker tabletop. 3. Support structures. Add extra legs or beam underneath, particularly in the middle, where the deflection is most likely. Number 4. Weight limits. Establish clear weight limits and educate students to prevent overload. Number 5. Regular maintenance. Conduct regular inspections for wear and tear. Repair or replace any desk that starts to sag. Number 6. Adjustable designs. Consider desks that can adjust in height or configuration to accommodate various uses and weights. Number 7. Feedback mechanism. Encourage students to report desk issues. Their feedback can highlight which desk needs to attention or replacements. Implementing these solutions will ensure our classroom desks remain safe and durable, ready for whatever chaos comes their way.
Si Subos ka talaga, kaya dami kong alam. Uy! Oras na! Kapunta mo pa.
Bukas ako. Si Little Miss Girl yung prof?
Ay! Oh my God!
Use the word little girl again to address me, or I won't guarantee your safety. Detention.